Hello everybody. So today I'm going to present my final assignment on data 605 subject. The first question is using R we have to generate a random variable x that has 10,000 random uniform numbers from 1 to n. So the capital N that I've chosen is as 20, and where that 20 can be any number of your choosing greater than or equal to 6. Then we have to generate a random variable y that has 10,000 random normal numbers. So here I have taken the small letter n and set it as the number 10,000. After that I have passed those parameters small n and capital N on the round function x, and then I have passed the parameters small n, the mean, and the standard deviation, which to us is given as equal in the question itself, that is n plus 1 by 2, and that I have considered as y. Moving on to the sub questions. First, I have to calculate as a minimum the below probabilities A through question C, assuming the small letter x is estimated as the median of the x variable. So here the small letter x is the median of this round function value, and the small letter y is estimated as the first quartile of the y variable, and then we have to interpret the meaning of all those probabilities. So let's get started doing that. So our first question is that to estimate that probability x is greater than the median small x, given that capital X is greater than first quartile of the y, and the first quartile we have taken it as small y. So here we calculate p probability of x greater than y, and then we calculate the numerator through this expression, and then we calculate the denominator, that is p probability x greater than y. So from numerator and denominator, what I mean is the expression that we have to calculate, this one, we can expand it as probability x greater than x or probability x greater than y, which equates the union of this expression and the probability of px greater than y divided by px greater than small y. So in this, what we have, the p capital X greater than the small x, we have the expression as 0.4, and px greater than y, we have it as 0.8. So that's how we get the answer as 0.5. And then proceeding on to the next question, similarly we have to see that the probability that x is greater than the median and y is greater than the first quartile. And here I did the process following the mathematical formula. We get the answer as 0.4 and the denominator as the expression py greater than small y as 0.7. Computing both of that, we get the value as 0.3. Now following on for the third question, we need to find the probability capital X is less than the median, given that x is greater than first quartile of y, that is a small y. So here we calculate the numerator and the denominator, and then following the values we compute it and we get the value as 0.4. For the next question, we need to investigate whether p capital X is greater than the small x, that is the median, and y is greater than the first quartile by building a table and evaluating marginal and joint probabilities. So here I would like to tell you what is a marginal and joint probability. So the joint probability is a probability that two events will occur simultaneously, and the marginal is the probability of the occurrence of the single event. So as we see here, for proceeding with that, we first need to find the Cartesian product of the data frame. So I do that process here, and then we find the table. Table of counts means we just formulate a table in which I have given the ABC, computed these three values. A is we get the A value here, B value here, and C value in the total column, and then we find the joint probabilities. And after finding the joint probability, we calculate the marginal probability, and as I told, that's the occurrence of a single event. So if we see here, px greater than x, small x, that is our first column, we get 4488 divided by 10,000. So This value we have taken from here, that is x greater than x, the total probability of the x greater than x. Similarly, for y greater than y, we have taken 7 to 4, 7. For concluding, we needed to investigate if this expression is equal to this expression. So as we see that both of them holds nearly true, the expression of AND is 0.3249 and the expression of OR is 0.325. The next question is to check if the independence holds by using Fisher's exact test and the chi-square test and the difference between the two. So let's get started by learning what is Fisher's exact test. So Fisher's exact test it's a statistical test used to determine if there are non-random associations between two categorical variables, and the chi-square test is used to determine whether there is a significant difference between the expected frequencies and the observed frequencies in one or more of the categories, and also that the chi-square test can be used to attempt rejection of the null hypothesis that the data are independent. So that's what we do here. If we start with the hypothesis that x is greater than x and y are independent, then based on the above, we would expect that the value, this expression, to be 0.325, but our actual value is 0.3249. So like if the probability of obtaining a higher value than 0.3249, that is deviating from the expected value, is small enough, then we would reject the hypothesis. Otherwise, the hypothesis holds true. Therefore, to find such probability, we use the Haifa function in order to find the upper tail for the hypogeometric distribution required for the Fisher's test. Doing that process here and computing the value for PHPR variable that I found from the Haifa function, I get the value of 0.5, and this value is large, and therefore based on this test, the hypothesis cannot be rejected, and therefore the variables x and y are independent. Now following on with the chi-square test, we find the x-square value for the above observations, and it can be computed as follows based on this expression here, where OI is the observed value and EI is the expected value based on the table of counts above. Now OI, we each term, that is O1, O2, O3, O4, holds x greater than x and y greater than y. Like these are all the values similar to the value held by this table, each value in this column, and that's the observed value. The expected value is the round of the product values of both divided by the small letter n, the value that it held. Therefore, we get the observed value and expected value of both, and with that we compute the chi-squared value, which we get it as 0.0192. Now to calculate the degrees of freedom, it is computed as follows: r minus 1, where r is the number of rows, c minus 1, where c is the number of columns. We get the value as 1. Now following with finding the p value for the chi-square distribution, we will pass on the parameter chi-square that we just found out to the p chi-squared function, and computing the lower tail as false. We get the p chi-squared value as 0.89. Now this value is large, and therefore based on this test the hypothesis cannot be rejected, and therefore the variables x and y are independent. As we saw above, both Fisher's exact test and chi-square test proved equally effective in testing the hypothesis in this case. Now that's it for the first problem. For the second one, we are supposed to register for Kaggle.com and compete in the house prizes competition, which is based on advanced regression techniques. The first question is we have to provide a univariate descriptive statistics and appropriate plots for the training data set, and then we have to provide a scatter plot matrix for at least two of the independent variables and the dependent variable, and deriving a correlation matrix for any three quantitative variables in the dataset, After that, we have to test the hypothesis that the correlations between each pairwise set is zero and provide 80% confidence interval. And later we will discuss the meaning of my analysis and if I would be worried about the family wise error based on the results of the analysis. So here let me explain the variables of the data set. So the GR live area is the above grade, that is above the ground level, and the year built is the original construction date. The bedroom ABVGR, this variable defines the bedroom above grade that does not include basement bedrooms. So first of all, we will upload the training data set, which is also provided in my GitHub. After that, we compute the standard deviation, mean, maximum value, minimum value, and we plot a histogram for the living area above ground level of the training data set. After that, we provide the summary of the training data set, a summary of only the sale price variable, in which we acquire the minimum value of 34,900 and maximum value of 7,55,000. After that, we will again compute the standard deviation of the sale price variable of the training data set, minimum, maximum, mean, maximum, and minimum value. After that, we again plot the histogram of the sale price. And then we repeat the process and plot the regression line for the sale price versus the living area. And here we see that it's a canonical form of the dots and some outliers here. So at this and also the residual analysis, it shows us that the plots are nearly normal and significantly linear model. After that, we plot the QQ norm, which shows us the same, that most of the points lie in the straight line. So to summarize the above graph, both variables are nearly normal, that is sale price of the training set and the ground level living area. And the scatter and the residual analysis plots indicate a nearly straight and significant linear correlation. After that, the scatter plot matrix below shows three independent variables, that is living area above ground level, bedroom area, and the year it was built, and one dependent variable, that is the sale price. So, and we have a correlation matrix here of our sale price, and that is our dependent variable and all the other three independent variables. After that, we perform a pairwise correlation testing, which was indicated that correlation between each pairwise set of variables is not zero, and using 80% confidence interval, we do the correlation test between the ground level area and year it was built, and then we do it between bedroom area above ground level, year it was built, and then we do it between bedroom area and the ground living area. So seeing all the three correlation tests, we and despite the hypothesis rejections, we would be worried about the family wise error, because given that there are a lot of observations and likelihood of the error is almost guaranteed. So following up with the next question, we need to invert our correlation matrix from above, and it's also known as the precision matrix and contains variance inflation factors on the diagonal. Now after that, we need to multiply the correlation matrix by the precision matrix, and then multiply the precision matrix by the correlation one, and then conduct the LU decomposition on the matrix, which I have done using a function. So we pass the MA value to the solve function, and then we compute both of these variables and we invert both of these variables. After that, we conduct an LU decomposition of the matrix, in which I have written a function here, and to verify that I have passed the MB variable in my function. And we also try to invert it to verify the prices and the matrix. Now for the next question, we have to select a variable in the training data set that is skewed to the right, shift it so that the minimum value is absolutely above 0 if necessary, and then we have to load the mass package and run this function to an exponential probability density function. And then we have to find the lambda for this distribution. So the first process I have done here, I have loaded the library mass package, loaded the variable ground living area of the training data system, and then passed that variable to the fitdistr function. After that, I have built an histogram as per given in the question. We have to find the optimal value of lambda for this distribution and then take 1000 samples from this exponential. After that, we proceed with it, and I selected the ground level variable, which appears to be somewhat right skewed, as we can see here, and also the histogram of the fitted distribution. Now, fitting an exponential distribution resulted in an optimal value, that is lambda equals to 7 into 10 raised to power minus 4. Now, as we proceed with finding the 5th and the 95th percentiles, we get the value as 77.7, 4539.9. Now generating a 95% confidence interval from the empirical data, assuming normality. So we passed the 95% confidence interval and this value to the Q norm function, now providing the empirical 5th and 95th percentiles. After that, we do that process and we plot the histogram of the living area, which seems to be nearly normal but a bit right skewed. Now, even though the data of this living area variables it appears to be right skewed, the interval numbers and the plots above show that it is better described by a normal distribution rather than, as we see here, an exponential one. Now, moving on to the next question, we have to build some type of multiple regression model, and then I have to submit my model and then provide my score, my kaggle.com score, and then I'll also summarize my model and result with analysis. So I have taken all these variables given in my training data set and I have stored it, loaded the data frame and stored it in the variable trn. After that, I pass those, I create a function called standard scalar and then find the mean and standard deviation of the parameter I pass to it, and then return a function x minus mean divided by the standard deviation. So after that, I load the sale price of my training data set and then I create a histogram. I create a linear regression with all those variables. We can see it as the sale price is versus the subclass, the zoning, frontage, lot area, lot shape, etc. And then I also generate a summary of my linear regression. After that, I have explained the steps here, that we remove the insignificant features and rebuild the model, remove features, lot config, and then all these variables, heading QC. After that, we do a backward elimination process. In that, we pass the hs.lm variable into the update function, and we also generate a summary for that variable. After that, we pass the hslm function versus the central layer in the update function and provide a summary for it. Proceeding with the same method, we pass the hslm with versus the foundation variable in the update function and provide the summary for it. We did the similar thing with the ms zoning variable, the ms subclass variable. After that, we do a residual analysis with the hs.lm function and draw a plot of fitted line here, in which most of the dots fall on the line with very few outliers, and this shows that our data is significant, like linearly significant, and that is quite verified by seeing our normal QQ plot. And then after that, we do a predictive response in which we train the data set and test it with our test set, the predictive responses, and then save that file. Uh, so after that, I impute the missing data, and then I derive and calculate the additional features, which is the year it was sold, year it was built, year it was sold minus also the year it was remodeled. I rescale the numeric data, use standardization. That means I subtract the mean and divide it by variance. And this way, the features are centered around 0 and have the variance as 1. And after that, I predict the house prices and provide a summary for it as well in here, in which my maximum value is coming as 57,000 and my minimum is coming as 3. And I create the histogram of both the predicted prices and training prices, which seems to be somewhat similar and nearly normal distributed. And yeah, that's it. And when I submitted my model, I achieved a score of 0.42. So thank you.